In this video, I will be showing you the parts of a graph. The first thing you need to do is identify what type of graph you're working with. You can do that by identifying the labels on each axis. Here we have speed, and here we have time. So we're working with a speed time graph. Speed time graph. The next thing we're going to do is identify our axes. Going up and down, we have the y-axis. And then going horizontally, we have the x-axis. So up and down is the y-axis. Horizontally is the x-axis. Now we're going to identify the intervals. And the intervals simply show you how the numbers are being counted on each axis. Let's look at the y-axis. Here we can see we start at our point of origin, which is here, 0. I like to call it the PO, point of origin. Point of origin. From our point of origin, which is 0, the next number up is 5. Then we go to 10, 15, 20, 25, 30, and 35. So we're moving in increments of 5. So the intervals are 5. That means from the point of origin to the next number up, there's 5. From the second point to the third point, there's 5. From the third point to the fourth point, there's 5. From the second point to the third point, there's 5. From the third point to the fourth point, there's 5, and so on and so forth. Next, let's look at the x-axis. Here at the point of origin, we have 0. Then we have 50, 100, 150, 200, 250, 300, 350. So we're moving in increments of 50. That means from the point of origin here at 0 to the next point, there's 50. From the second point to the third point, there is 50. From the third point to the fourth point, there's 50. From the fourth to the fifth, there's 50, and so on. Next, we're going to identify what's happening on our speed time graph. Let's look at this first line. So we can see from the point of origin, it starts here at 0. From the point of origin to the letter A, this is showing a constant speed. So this is constant speed. And what I mean by constant speed is that here at the point of origin, where it started here at when the time was 0, we started at a speed of 10 meters per second. 10. When the time was 50 seconds, we were still at 10 meters per second. When the time was 100 seconds, we were still at 10 meters per second. And when the time was 50 seconds, we were still at 10 meters per second. So there was a constant speed of 10 meters per second. So this line represents a constant speed from the point of origin to the letter A. Now let's see what's happening from the letter A to letter B. Here we have from letter A to letter B. This line is showing an increase in speed. Increase speed. So the speed increased. So it went from the 10 meters per second all the way up to 30 meters per second here at point B. So the speed increased. Now, from point B to point C, you see another flat line. And this is going to represent constant speed. So let's say we're at point B, we're at 30 meters per second. At point C, when the time is 300 seconds, you can see we're still at a speed of 30 meters per second. That speed has stayed constant. Now let's look at this last point from letter C to letter D. You can see the line is going down, and that's going to represent a decrease in speed. Decrease in speed. You can see we went from 30 meters per second all the way back down to the point of origin, which was it's going to ultimately go down, and it ended up being at 5 meters per second. 5 meters per second. So this is your speed time graph.